All right, final problem here. Rate of change for the 2 points b, p of b, and b plus c, p of b plus c. We're going to use this function, p of x equals x squared plus 6x minus 3. Again, I know these are a little more difficult because it doesn't just say x, f of x, but if you know it's a function, the notation means to do the same idea. So we're going to do the same thing. So for rate of change, we know that's slope. Let's get our organization correct again. So this will be point 1. That's x1, y1. That's x2, y2. That's point 2. Does it matter which one is point 1 and which one's point 2? No, it doesn't. It seems to work out easier this way usually in terms of when you have to subtract for slope. And we don't get any negatives this way. So I like to keep it this way, but if you want to do it the other way, that's okay too. We should go to the same place if you do it correctly. So for y2 minus y1, that's p of b plus c minus p of b over that quantity for the x's, that's b plus c minus b. Okay, so how do we get values out of that? Well, how do you evaluate b plus c? So that's what p of b plus c. Again, just take b plus c, that whole quantity, where we see an x, that's where that's going. Here we go. So substitute that in b plus c. So I'm going to start with x squared plus 6x minus 3. And then notice leave a blank again. And for the x, I just write b plus c. Where we see an x, b plus c. So one point I want to make, there are no more p's in this equation, right? Like once I get to this step, there's no more p's. Okay, p of this and p of this, that means substitute something in. Now we've done that, so there's no more p's, right? B of c is substituted in, so that's what function notation does, but now we're done with the p part for that, okay? Let's not forget about p of b though too. So for p of b, let's plug a b in for each x squared. So that's minus, and then I'll put x squared plus 6x minus 3. What's going in there? B's for each one. I'm going to color code it. Use red. B and B. Okay, so at this point we're good. We've got a lot going on up top, but everything's been substituted correctly. There's no more p's. Now we've evaluated, we've got values. And in the denominator, we have b plus c minus b. So the b's will cancel. We'll just have c down in the denominator. So let's start there. So make my fraction again. I'll make it long. Let's start with just a c in the denominator. Okay, so first things first. B plus c squared, that binomial, let's square that. And again, I'm not going to go through the process of foiling it. I'm going to talk about the pattern for squaring a binomial. I'll put my parentheses here. So first term squared, that's b squared. Multiply them together and double it. So b times c, double that. So that's 2bc. And then last term, c, let's square that. Cool, so that part's done. And let's not forget about the 6b plus c there. So let's go ahead and distribute that 6. So now we've got plus 6b plus 6c. And then another thing, easy thing to forget about, don't forget there's a minus 3 right here, so let's carry that along too. And then this quantity, just get the negative through there and we should be okay. So distribute this negative through each one. We should be alright after that. So now we got minus b squared minus 6b plus 3. Long and lengthy, but so much of it's going to cancel out. So looking left to right, we got b squared and minus b squared. 6b, I see a 6b and a minus 6b. What else do we have left? We got 2bc, c squared, 6c. Oh, we got the 3's, right? Minus 3 and 3, those are gone. So now what do we got? 2bc plus c squared plus the 6c there, all over c. Okay, so because each term in the top has a c, we can cancel a c out of everything. And again, the mathematically correct way to say that is if we can factor the top of that, the numerator there. So what comes out of everything? GCF. Looks like they all share a c, so c, and then we've got 2b plus c plus 6 all over c. And then let's go ahead and cancel the c's clearly out front there. So we have our final answer, 2b plus c plus 6.